Today we are going to practice using the secure hash functions. I will first show you how we compute the hash values using OpenSSL Digest command done by using the MD5 and shasum tools. Then after that, I will show you how can we evaluate multiple files and verify the download files using these hash values. So you can create a folder within your virtual machine, and let's see some examples here. So I'm going to try to show you how can we compute the hash value using the OpenSSL Digest. Okay, if you went to the OpenSSL source code, we have that available us with it contains, say, different version, of course. I think the current version comes with two hash values, 160-bit for the SHA-1 and 256-bit for the SHA-256. And also MD5 is available there. Okay, let's create a file. I'm going to CS458 is great class. Okay. And you know what, -n, I don't want to have it to be part of the data. So create this one and put this one in the file. And if you say create this file, and this is going to give me the content. Okay, great. That's what I have. Okay, the files exist there. Good. Now after that, what I'm planning to do here, you can go with the OpenSSL or let's say I'm going to go over the OpenSSL list digest command, which is going to be list, give me all the list of the digest mechanism, which is going to be available, which allow me in order to help me in order to build the hash function or play around with the hash function in general. So if you take a look at the link here, OpenSSL, this is a command, the same thing that we did before when you work with encryption. This one will give you an idea about all the command that I can use here. I can do MD4, I can do MD5 as a command, I can use SHA and SHA-1 here. Okay, good, that's what I want. Just be clear. Okay, we do have OpenSSL using encryption, and we do have another option using digest, dgst, which is message digest calculation, and allow me in order to compute the hash function. If you want to the OpenSSL, the document is fine. This is just to give you any information about the digest. Remember, when you talk about the encryption, when you use OpenSSL and ENC as encryption, we went to the manual, and the manual shows us the different command options we can use. It's a good idea because you need to know what the structure of this command in order to help you in order to see what we have. Let me go over here. I think I can open this one. I think my computer is doing download for something. I don't know what they're doing. And see here what the option that we can perform here. You can specify the input file. You can specify the output file. We're going to put the outcome. You can later, we're going to talk about it. We can use this one in order to sign the data. I'm going to do this one later, not today. Sign the message. You can use this one in order to perform verification for the digest, because it looks like you can sign the message, compute the hash value, then after that, sign the hash value. Use the key. Then after that, you can use this one in order to verify, the signature of the signed, let's say, hash value that you have. Okay? You can use this one as HMAC. We're going to cover this one later. Okay, need this one anymore, and get back here. Okay, this is the link. Oh, you can Google here. Make sure that you're gonna go to the manual for the OpenSSL stored in your machine. Okay, let's see how can you compute the hash function or the hash value for the file that you have. So I'm gonna show you here. This is the place. Okay, OpenSSL digest space. I'm gonna say dash MD5. I'm gonna use MD5, and the input is gonna be m.text. I'm not going to store this one. You can, if you want to store the output, you can use this one and specify the output. It can be whatever file. But right now, I want to show you what is the message digest here. You see that? This is the message digest. And it depends what the size of the MD5 here. As you mentioned, the MD5 is 128 bits. Okay? So that's the first one. What else? What if I want to store this one in the file? So it's interesting. This is the one hash function. I compute it, and I wanted to store this one in the file. I'm going to do this one again. By the way, the hash function is a deterministic function. So every time you compute the hash value for the same file, is always produce the same result. I'm going to show you. We compute the first one here, and we displayed. Now I'm going to compute it again here, and store this one in the file as well. Okay? Now if you said cat, let's say s.value here, and now you see it can be the exact hash value that we have here is exact match this one. If you do this one again and again and again, let's do this one like this for fun. I do this one time. Okay. I do this one again. And you see, all is going to produce the same hash function as long as we didn't touch the message. You don't modify the message.
Okay, assume that we have another file, and this file, I need just to have a different file. I will store this one. Of course, you have to say this class is fun. You can't change this one to unfun, not fun anymore. Anyway, you put this one in the file. Now I need to compute the hash function of this file and put this one, for the example, on another file. Okay, so in this case, you're going to perform this operation. OpenSSL Digest -MD5. This is the input from the M file, M1, and the output is S1. Then I'm going to compare both of them. Just I wanted to display the two hash functions that we have. The S for the first message M, and the S1 is like the hash value for the second file. Do you think it's going to be the same or not? It's not going to be the same because the collision going to be. You see that? This is one file for the first one, and this is the second hash value for the second file. What else after that? What if someone will say, can you use SHA-1, for example? Yes. Just I want to show you what if we use the SHA-1 here. So I'm going to use OpenSSL -SHA-1 for what? For the same file M, okay? So the same file. So S is going to be the hash value of the message M using the MD5, 128 bits. And the SHA-1 is going to produce 160 bits for the same file. And I'm going to store this one S_SHA-1.5. Then after that, let me do this one S_. Yeah. I need to compare the hash value for the MD5 for the same file and the hash value with the SHA-1. You see the difference here? Now it's getting bigger, larger. 128 bits, and this one is going to be 160 bits. Okay? You see the difference here? Each of them, they're going to produce fixed length, that the size depends whatever the hash algorithm you're going to use here. Okay, so can you use 256? Yeah, let's do this one. Then after that, compare it with the whole thing here. Okay, I'm going to try to compute the SHA-256 for whom? For the same file M, and store this one to the SHA-256. Then after that, I'm just want to, let me clear this one first. If you want to display all of them, S_256. Okay, you see that the size? The first one produced for the MD5, 128 bits. Divide by 8 to give you how many bytes. The second one is going to produce what? 160 bits. Divide by 8 will give you how many bytes. The third one with the hash value that you computed using the 256. Divide by 8 is going to give you how many bytes that you have. You see that? Good. So that's great. We know that for every single hash function, it's going to produce specific hash value, and the size is going to be it depends on the hash function that we have. For the same file, can you find anything, for example, matching? No, I can't tell, for example, because it's completely random. And if you compute this one for the same file, it's going to be always produce the same result. Okay, so far so good. When you download the file from the website, I encourage you, I advise you to check the integrity, which is going to be a good idea to verify, the download file is valid. Okay? Generally speaking, the website is going to just check, okay, of the hash value for each file that you can use to check the integrity of the file. How can you check the integrity of the file? Take the file, compute the hash function, then compare it with the hash function that provided the website. Which hash function you're going to use? It depends. The file or the site website, maybe you're going to say, we use MD5, we use SHA-1, SHA-2, so we have to use the exact hash function. Then you can. If you haven't found match, that's fine. Just make sure I'll give you like comment that whatever you download, this is the one that you found there. Okay? Most of modern system, operating system, they have a utility is already there, which allow you in order to perform the computing. Okay? These such hash functions. Linux has MD5 sum, has SHA-256 sum, yeah? OpenSSL itself is going to provide similar, let's say, command line utilities. So you have two different ways. Either take the file, compute the hash value using the same way that I showed to you using OpenSSL, or maybe use some commands already there. For example, you can use MD5 to compute a sum in order to check you compute the hash value, use MD5, or SHA-256, SHA-100, whatever the value, 512, some which allow you in order to perform tasks. So you have different ways, okay? OpenSSL or whatever the operating system provides there. Okay, I'm going to talk about the MD5 sum which is already there in the Linux system, okay? Which is going to produce, 128 bits, right? So how can you display this such value? So the simple thing, let's do this command, MD5 sum, which is going to compute the hash value the same way. Either you're going to use using OpenSSL Digest -MD5, or we're going to use this one for the same file. Yeah. If you see cat, I think we call this one S1, yeah, for the same file. Yeah, it'd be the same. So this one definitely is going to produce the same hash function, regardless of the way that you compute it. Either use MD5 sum or use the OpenSSL library, whatever that provides us with some command we can use. Okay, that we did too. So this is MD1 sum. We can perform that. If you check, if you want to convert this one, you can use open, as I mentioned, open digest -MD5 with the out from the file M1, or we already have S1 stored there, so I can compare both. Okay. So now how to validate the multiple bytes, or to say a set of files that store there. By the way, this is the similar thing that I require from you to do in the lab 3. In the lab 3, you're going to take a look at the collision for the MD5. How could you achieve the collision? And there's some tools that are going to be too easy to defeat the MD5 hash function. Okay? One task that I'm going to ask you to do to come up with the two different files, or two files. They have two different functionality, but they have the same hash value using MD5. Okay? So anyway, before I do this one, well, how about if you have many files, I need to validate them. I need to check the hash value of them. So that means you have file 1, file 2, or file 3. I don't want it to do one at a time. I want to do this one together. So you can use this command, okay? In order to compute the hash function with the hash value for two files, you say mdsum, 5sum, take the first file M1, and the file M2, compute the hash value, then stored in the file. That's what we're doing in order to check, bias detection, or check the intrusion in the file system. This is a simple, naive way. Remember when I said you need to compute the hash value for every single file, store the serial location. Then after that, you need to compare this one to check later in order to see whether you have anything in your system, whether someone has changed or modified the files or specific file. How could you catch this one? This is the way how to do that. Okay? If you take a look to the hash, or you want to check this one, instead to do this one at a time, I'm going to use MD5 here, check the file here. So what does that mean? This one is going to go for every single file M1 and M2 that you use. It's going to compute the hash value, then compare it with the one stored in the file. You see, that's what happened. That's one interesting thing, actually. You can do this one, even in your application. If you have one code, simple code, you can check with the file, the integrity of the files. Again, so the first one here, I did what? I compute the hash value for every single file, and store this one in, let's say, a specific location, a specific file. Later, the hash is going to be whatever the name you're going to call, okay? The output file is going to be stored the secure location. Then after that, now when you need just to check, make sure whether there is any virus in your system, whether anyone to change any of these files, so the system is going to do what? For every single file that we have stored here, for the hashes, compute the hash value, then compare it with the stored hash value there. If they found any mismatch, they're going to say, or unmatched, they're going to say, it's not okay. Right now, we didn't change anything in M1 and M2, okay? So what I'm going to do right now, I'm going to change the M1. When you change the M1, this is one way, by the way, you can change M1. So assume that I'm going to use the nano or whatever editor. Assume you don't like my class. So the change, Control X, and yes here. Now if you take a look at the cat to say M1, just I want to show you what the content of M1. Now it's going to be, it's not fun. I modify this one. We modify only the file. Assume that someone modified the file. Now I need to check. I'm going to say MD5 sum, check the hash. See whether any of these files stored there. Someone modified them since the last time we compute the hash or not. The system is going to check and say the first one is okay, the second one is failed. Why? Because the hash values changed. So that's a simple, interesting thing. Yeah, you can do this one for all your files. Clear? In order to see the content of the file, here's a hash is here. It's going to be this one that contains the hash value for every single file. That's the content here. So you see, for when you try to check, you can recompute the hash value of every single file, then compare it with the value that's stored there. If it changed, then it's going to say, oh, something changed. So let me MD5, for example, MD5 sum, let's say for the M1, just I want to see what the hash value of this one. You see, this is the stored value for the one that we computed before we modified, and this is the new one after I performed the modification. See? They are different. This one is different than this one. Okay, clear. This one, hopefully, I just need to clear the terminal. If you want just to display the modified files, for example, you have 1000 files, you don't need to waste your time, you can use the quiet option here. The quiet option, for the check, you're going to here just show you the files that fail, the modified file, hash value don't match. Okay? Remember that we said, so I'm going to ask you to create, say, two different files using C or whatever language. And these files are going to have different content. In other words, they have different tasks, yeah? But they're going to produce the same hash value. Okay? I already have these files, okay? So be sure here. I do have file 1 and file 2. Just I want to show you, stored in this folder, okay? If you take a look at the checksum of them, they have the exact hash value. Okay, let me execute the first one, and this is the file. File one is gonna just say hello world. Okay, press request, enter to request. Okay, the file two gonna have different tasks. So that's what remember. If we manage to have two files, either one of them like do something good, this other one maybe they're malicious. They had some malicious activity, maybe delete the entire content of the disk or whatever. So if we manage to substitute the file one with the file two, both of them have the same hash value, so I can track the system, yeah? I can fool the system in this case. Let's see. File two is going to produce the following. It looks like evil program. It's going to delete erasing the hard drive. Of course, it's not going to delete, but just show you that this file, or the file one, has different outcome from the other file. Both of them, they still have the same hash value. How could you do this one? That's the one that you're going to go over. There's many steps in the lab, so allow you in order to use the MD5. Yes, it's easy to do that. That's why it's not secure. Okay? Because they can substitute a file with another file. Both of them are going to have the same hash value, different contents, which is not a good idea. Okay? Good. Yeah, if you wanted to compare these files, you can, by the way, there's another command you can use in order to compare the content of the file. This one, the compare CMP, is going to show you the first location where these files going to be different. They're starting from this byte 1876, the line 9, starting here, these files start being different. If you want all the location where these files going to be different, you're going to use this command, -L. Just to give you all the bits where it starts. This is the first byte, and the second, the third. These all the locations of this file are different. So this command is interesting, it's useful, it's help you in order to see or find out or compare two files. Okay? You can, by the way, use SHA-512 sum. You can use SHA-256 sum. Let's go over example here quick. SHA-512 sum, so produce the size, as far as the hash function, 512 bits. Okay? If you use, let's say, what if I use SHA, let's say 256? Just I want to show you the difference between them here. I'm going to use the same file. You see that, 526. And this one is double. Okay? So this, you see that, this is the larger. Okay, hopefully that convinces you the different hash function will produce different outcome. And the larger the hash value, or the more secure, of course, the less less efficient. It's not good. For example, the MD5, let's say, the SHA-256 is going to be faster than the SHA-512. I mean, it's not a little bit clear. For example, you download the file. Now you need to check the integrity of the download file. Okay. So let's go here, for example, just for example, I will show here. You download the virtual machine, the virtual box, okay? I wanted the virtual box, okay? You see that when you try to download the file, they're gonna give you like a checksum. They give you one for 256 in this file, or the MD5. Either is fine, okay? You can use either of them. So I'm gonna use 256, okay, to check this one. Good. How can you perform that? After I download my file, I'm not going to install this one. If you check this one, you need to figure out, in this case, the VirtualBox is going to have different options, different versions. Okay? I guess in our case, or my case, I download this file. So make sure that which file you download. I download this one. So some websites have only one unique file to download. So it's going to provide you with one, for example, checksum. Whether it can be SHA-256, MD5, SHA, whatever, 512. Whatever the SHA value that provides you, that's the one that you will produce. So for me, that's what I download, this file. That's why I am going to use this SHA value. Okay? Let me go back. After I download this one, I'll just show you the files here, ls. I already downloaded the file. And this is the file that I download. Okay? You see that? So based on this one, I know the hash value. So now, in order to check this one, you have two different ways. The simple one, I'm going to use for example, SHA-256 because I know the value. They give me SHA-256, right? Okay. Then after that, because what he did here, VI R, then VRI. Anyway, it's going to produce the hash value. Since you know the exact hash value, so you can use GRP, okay, that we used before. Remember the command? I think since I made many mistakes, I think it's time to stop. But it's almost done, okay? So I'm gonna share whatever the hash function that we produce. This is the file. Then I'm gonna say after that I need just to locate what the hash value that I expected. So when we perform this one, let me compute the value sheet. If they are the match, they're gonna highlight it. Since they have the highlighted, that means yes, this hash value is correct. If you found any bit or byte, I mean different, that means don't use this file because something's suspicious here. Okay? Thanks guys.